I'm Justin Eckerling. I'm the operations manager here at GFI, and GFI is a company that formed in 2001, and we were looking at doing things a little bit differently. There are a lot of our competitors use very expensive pumps, and we were looking at bringing something that could go to all printers, not just the highest end of printers. Basically, what the printers do is they have our equipment in their press rooms, and it allows them to create a custom formulation to bring out to their presses to have special colors on press. Some of our company core values are innovation and quality. That is one of the reasons why we came to Graphic Systems and said, hey, we're having a problem. We need to solve this problem. What do you guys offer that can help us in this? We were users of SolidWorks originally, so it just made sense to call them to find out how we could use SolidWorks in tune with some other of their products. Failures that we're having is on one of our product lines called the mixer. This is the MXR10 mixer, and we were seeing several different product failures. There was a shaft that had linear bearings on it, and the linear bearings were burning out very quickly. We had no idea what loads were there. We were just kind of guessing, saying, all right, let's put our best foot forward and see how long they last. We also had a motor shaft failure that was due to an unbalanced load. As you'll see in some of the motion analysis later on, we have loads going in several different directions. Basically, we're creating an unbalanced load and trying to balance it with a counterweight. And when that unbalanced load was there was excessive amount of vibration on this piece of equipment, and which then caused bolts and other things to start backing out that then caused those to break, and then the customer calling us. Some of our initial troubleshooting was we called Graphic Systems and asked them what they could do, but before we did that, we also contacted a couple other companies. We contacted ANSYS. They were very reluctant to talk to us because we were a small business, and they just felt that we could not use their software or couldn't even afford their software at that point. The way we were looking at it was, hey, this is costing us a lot of money out in the field. We need something right away to fix this problem. We also contacted some companies that did some dynamic balancing. With dynamic balancing, because we're creating an offset, this kind of threw the people, because normally what they're doing is they're just trying to balance a motor that's running a fan or something like that, and the fan's unbalanced, where we're actually balancing an unbalanced load on purpose through a counterweight, and it was a very hard thing to tackle. We spent probably a day with the guy that came in here to try and analyze this, and at the end of the day, we basically had no better results than at the beginning of the day. With us being a customer-focused company, we were trying to solve these problems by just throwing the exact same thing we were doing at them without making any changes, because we didn't know what changes to make. That was costing us a lot of money. So looking at it from the the cost side of it, it was already costing us a lot of money with the field failures. The risks, well, we just wanted it fixed. I mean, that's the bottom line. The software by far saved us more money than what if we had to keep changing these things out in the field. We looked at a couple other design changes as well, adding some real strength to the motor shaft, bearings, and stuff like that. We looked at what that was going to cost us, and basically to retrofit 10 units was going to be the same as what the cost of the software was. We have 100 units out there, so right there we would have been 10 times what the cost of the software was just in fixing it, and we were just putting a Band-Aid on it. We weren't 100% sure that when this would go out, we weren't going to get another phone call saying, hey, we just have another problem now. So the software showed us basically everything that we were having problems with. After Dee was here and kind of showed us what the software could do, we had my engineer Sentil take over. He had a little bit of experience with some analysis, but not a lot. For him to pick this up was very easy. Once we got the software, then we did further studies on our shafts and that have bearings sliding up and down on them, and determined that some of the forces on those were also higher. So we had to change out the bearing to one that could absorb that load. Basically what we did in the end was we found out what the problems were, determined what we had to do to those problems, and then fixed those problems to our customers. When we were having motor failures, we were replacing motors, we were replacing bearings, we were having shipping there and back to fix these things. We basically solved that with a $18 counterweight. The amount of savings is huge on that, because how many more times will we send out the same problem and have the same problem again? And that was all solved by a very small part. Basically, using the software, it would show us exactly what weight we had to create for that counterweight. And having that then gave us the confidence that we were going to be moving forward in the right direction and wouldn't have problems again. When we first bought the software, there was some hesitation on whether this was even going to work or not. And when they first heard the first unit start up after we made all the changes, they were very amazed at how much quieter this unit went. I don't have decibel readings from when we were originally to where we are now, but you know, it used to be, oh, our machine's so quiet before, and when they heard the new one, it was like you couldn't even hear it running. It significantly changed some of the non-believers in the software to show them that this was something worth our while to move forward on. Our goal is to start moving forward to some of our current products and reducing some of the costs involved in those. You know, when we designed originally, it's just make it so it's as strong as it can be. Put the biggest tube on there we can without making it look goofy. What we're looking at now is going back to some of our older products and looking at those and reducing the cost by reducing materials that would then just be strong enough for that application. A couple customers, this was their 5th, 6th mixer. They were kind of getting upset at us, like, are you guys really fixing the problem this time? We basically showed them the analysis graphs and wrote up a technical document stating this is what it was before, this is how we're moving forward. The customers that saw that, they were blown away that we even took the time to just solve the problem. I think a lot of times they thought that it was just falling on deaf ears when we were telling them, you know, oh, we're going to fix the next one. And finally they actually saw some real data that showed, yeah, we did in fact fix it. Now our customers are confident in us. It also shows us as a customer-focused company that, hey, we saw these problems and we're addressing them and we're fixing them. So you're having the problem, we're going to take care of it. We're focused on our customers. It's all about making the customer happy in today's economy and everything else that's going on. And the more people we can make happy, they're going to talk better about you. And that's why we decided to go with the way we did.